Okay, so we're moving into chapter 9, and this is the first of our second to the last series of videos, okay, which is really exciting for me. Woo woo. So, chapter 19 is all about momentum. Okay, it's another conservation idea, and we've seen these ideas before. And specifically, what we were dealing with when we did momentum before was we would write something like we'd say our final momentum, um, let me write it just a little bit differently, minus the initial momentum was equal to an impulse. And we said that was an F dt. Okay. If we start from rest, we can toss that term. Okay. That sort of thing. If the force is constant, this becomes an F delta T. So you may want to take a moment to go look at your homework previously on some of those things, because all of those ideas translate into what we're doing right now. Okay. Now, rotationally speaking, we're going to have the rotational final momentum minus the rotational initial momentum is going to be equal to the moment dt. All right. Now, if the moment is constant, that becomes an m delta t, just like that. If it's not, then we have to integrate. Okay. That sort of thing. If we start from rest, we get to toss this term right here. All right. Now, we are going to introduce something just a little bit different, because the reality is we could have multiple forces acting on our translation. So really what we need here is we need to call this the sum of the integral of all those forces working together. And then with moments, it becomes the same thing. We got to add those guys together. Okay. All right. Now, so a lot of times what we do is we just end up writing our relationship like this, okay? Which you can see it's the same thing that we have before. I just moved this term over to this side, okay? So let me get rid of a few things that we're not going to need, and let's work this problem, okay? So we got this wheel. It's pretty massive, okay? The mass is 60 kilograms. They give us a radius of gyration there, so that's pretty cool. And we want to know what's the angular velocity of the wheels. That's our target. Okay, starting from rest at some particular point in time, 4 seconds. 4 seconds later, okay? Since we're going to be starting from rest, then we're going to be able to toss that term right there. That term's going to go to 0 for us. Now, the wheel has a particular moment acting on it. We don't know where this moment comes from, an axle or something, presumably, that's operating on it. But nonetheless, there's a moment there. And we're going to need the moment of inertia of this thing. All right. And so we'll take it about the center. It's just an mk squared because of that. And when you run the numbers on those, what you're going to get, IG, turns out to be 5.4. Okay. Now, let's talk about let's go back to basic just a little bit more. When we talk about momentum, it's a quantity of motion. It's a vector quantity. And we said it's some inertial term times a velocity term. Okay. So our inertial term is the scalar operating on our velocity term, vector v. Okay. Angular momentum is going to be the same thing. So we need an inertial term, so moment of inertia, and we need an angular velocity term. So again, we've got an inertial term acting as a scalar onto a vector velocity for us. Okay. Okay, let's bang this boy out here. Okay, so HF is going to become IG omega final And the only force we have, the only moment we have, is the one that's given to us there, which is 3t squared. And so if we substitute in there, we've got 3t squared. Whoa, not sure what happened there. My brain got ahead of my pencil or something. So we have that right there. Now, super simple integral. You could do by hand. You could pop it into your calculator real quick. But whenever you do that, what you're going to get out of that guy is 64. Now, the limits on that thing are going to go from a start time to the stop time, okay, which in our case is 0 to 4. Okay, so now we just do a little bit of algebra, and we get 64 over the moment of inertia. And when you carry out that math, you're going to get 11.85. Okay, so that's as simple as they get, but it illustrates lots of different things for us. Okay, shows us our primary equation we're going to be using, the one with the red box on it right there. And we're going to be using that over and over and over again. Okay, so the next few examples, of course, are going to get increasingly complicated, and we'll have some fairly complicated examples that you're probably going to want to kind of stop and think about. Stop the video, think about it, stop, go a little bit further, stop and think about it. Okay. So make sure, if we were in class, this is where I would say, okay, explain this to your neighbor. All right. And I'd ask everybody how they were feeling. And so anyway, make sure you're good to go with this, the simplest application ever. Okay. And I'll see you in the next video.